Alright, so really nice thing about this grinder is this plate can be turned 90 degrees and you can adjust it so that it comes out further. And I have it set to a 90-degree angle with a square. That means I can bump this up to it and make sure I get a perfectly uniform grind all the way up this. So that's really helpful if you need to get a long 90-degree flat spot. I'm going to try this out now. Alright. And now that is good to grind. So I need to make 4 completely uniform hollow grinds. Like one basically on every side of this. So that'll really help having that completely squared up. Let's show off this bad boy, shall we? I have a blank that I need to cut out. And we're going to do it on my new portable bandsaw. Gonna put tension on the blade, put some hearing protection on because it's pretty loud. Cuts very close and cuts down on the amount of grinding I'll have to do. So that's very nice. Also makes arguably less mess than the angle grinder, so it'll be nice for blanking out knives for sure. I need to rig a foot switch or something for it though, so I can use both hands and not have to hold this button down in the bag. Alright, and that's ready for grinding. Good deal. So today I have 2 ADC-RV2 daggers. They're just going to be test blades. I've never heat treated ADC-RV before, so I'm going to kind of see how it goes. So we're going to get them heated. Then after that I'll normalize the blades, quench them in oil, and then we will temper them later, probably at 2 different temperatures, and then we'll stress test them. I'm going to normalize the blades 3 times, and then I'll bring you back for the quench, because the normalization's kind of boring. It's just heat it up to non-magnetic, like once, let it cool down, do it again, let it cool down, do it again, let it cool down, and then it's good. Alright, doesn't appear that we warped or anything. That's good. That was quenched at about 116 degrees, I believe. This will naturally heat up the oil for the next quench, so we'll have to be a little bit considerate of that. That's why I wanted to do the thinner one first. As warmer oil will quench faster, so the thicker one will be quenched a little bit faster than this one. We'll check the rock wall hardness in a little bit. It looks like we got good martensite formation though, so that's good. You see that like gray, let's see, right in and around here. That's good. That's a good sign. Okay, that's good. We're at 125, so it only raised the temperature roughly 10 degrees. Alright, number 2, here we go. That one was probably a little bit hotter than it needed to be. Looks good though, it's not warped. There is a slight bend in it, but that's from grinding before. Like, that's a problem with this technique, or the grinding technique I used on this one versus this one, is I got less accurate results, but we'll see. I'm thinking the grinding technique I used for this one is what I'll be doing for the final knife. Alright. Oh yeah, definitely got some martensite formation on this one. You can tell the light gray is way more prominent, so this one is certainly hard. This one I'm a little bit worried about, but we'll see. So I'm gonna let them cool down just a bit, and then we'll check with the Rockwell files. Okay, both of them have cooled down pretty well, and I have gone ahead and sanded one like spot on it basically, or one I don't know, whatever you call it, dimension. And we're gonna see how, let me zoom out just a little. We'll see how just the basic file test goes first. Well, with just a basic file, that's absolutely hard. So that's good. That doesn't grab that at all. See how the other one does. Oh yeah. Absolutely. Okay, that's great. God, that's like super hard. Let's see exactly how hard it is. I'm gonna start with 6, or no wait, we'll start with 65, the highest, and work our way down. Does that sound smart? Alright, let's see, this is the thicker blade. Make sure I'm in shot. Gotta say, if that's digging in, it's not digging in much. We'll see if there's a difference between 65 and... Oh yeah, 60 definitely doesn't dig in. 65 digs in a little bit, so it's probably sitting at about 63 Rockwell hardness. That is tremendously high. That makes me want to temper them immediately. This one is also absolutely harder than 60. Let's see. And the 65 one just kind of... 60, like I swear, the 65 feels like it slides off of it also. Makes me wonder if I'm getting it in a good enough spot. I've got the edge cleaned off, so. Yeah, Okay, these are absolutely hard. They're like ridiculously hard even. So I'm gonna take them in and clean them up, and then we'll get them ready to temper. Because I feel like the sooner we temper these, the better. Because they are really hard.
Okay, so the blades have been heat treated and tempered. So the something I observed is that the thicker one, the tip, although it was ground a little bit crooked to begin with, I think did warp also. So that kind of tells me that I need to, I also have a little bit of a wave here. Which tells me the other blade, the thinner one that I quenched at, I believe it was 116 degrees. It tells me that this steel probably does better in a slightly cooler quench, because this blade was thicker than this one, and this one stayed completely straight because this one was quenched in a cooler oil. So we're going to probably go with slightly cooler oil. I also might have quenched this one just a little bit too hot, so I need to really watch my temperatures, what that tells me as well. But overall, like, they're looking decent. I'm going to test the Rockwell hardness now and see where we're at post-temper. We're going to start with a 60 file. We should absolutely be lower than 60 at this point, because this one, the thicker one, was heat treated at 400 degrees for 1 hour, allowed to cool, then 400 again for another hour. This one was heat treated at 415 for 1 hour, and then allowed to cool 415 again. So 2 cycles of 400 on one, 2 cycles of 415 on another. Okay, 65 digs in. 60 kind of just barely digs in. We'll see if that means 55 skates. Feels like 55 is skating, but we'll just check to be sure. Good basis of comparison. This is a 50 Rockwell hardness file. Yeah, and that doesn't want to grab at all. To be honest, the 55 doesn't feel like it wants to grab much either, though. That's making me wonder if I need to temper these even further. Let's see how the 415 one handles. Get my files in order. Alright, does a 65 grab it? Yeah, 65 absolutely grabs that. I believe a 60 is grabbing it as well. Let's see, does 50 skate? 50 skates, so okay, never mind. This one seems like it's somewhere in between 55 and 50, I'm pretty sure. For this kind of knife, that's probably a good thing. because it's not going to be experiencing a lot of like shock, but it could be experiencing like a form of force that might make it bend or try to snap like this way. So we'll see how the brake test fares with this. This one I'm a bit surprised at though, because it's like I tempered it and it's almost like it didn't seem to have much of an effect. Either that or it's between 60 and 55. It seems like it could be between 65 and 60, which is still surprisingly high. So that at least offers me a decent amount of information. That means that if neither of these heat treats work, or if one of them has a pro and one of them has a con, then I can just split the difference. Next thing is I'm going to put a rough point on both of these, because right now they're pretty like rounded off. This one especially, so it's almost like a chisel. And then we're going to do some testing basically and see how they handle certain stresses. Alright, here we go. Got some quick and dirty points put on these, just so that they're thin enough to kind of test the strength of the points. I'm going to start by basically hammering these straight into some wood and see if there's any deformation. If there's any deformation with something like that, that's not a great start. So we'll see. This should be fun though. Alright, here we go. Testing the softer one first. Haven't given it much thought as to how I'd get it back out. Man, that is stuck now. Okay, let's try the second one. Won't put it quite as far. Alright, the tip on this one is completely fine, so that's good. I'm going to work on getting this one out carefully, and then we'll look at the tip on it. Okay. After some wiggling back and forth, I got it out, and the tip is completely fine, so that's fantastic. Alright, next test. We're going to drop it point down on some wood. We have a wooden floor in the shop, so that's what we'll be using. I'm going to start with the soft one first. Okay. And now the hard one. Alright, well, the points are probably pretty good. I wasn't expecting that. Yeah. Both of these are completely fine. So, congratulations, they passed the easy stuff. On to the harder tasks. Now we're going to drop them on some brick. See how they handle that. This is the thick one first. Ooh, that doesn't sound great. Now the thin one. See how they do. Dang, surprisingly still just fine. You want to see that? No bending or deformation or anything. So far, this pretty impressive steel, I'd say. I'm gonna do it again. Nice. This is the thinner one. It is completely fine. This is the thicker one, and it is also completely fine. Wonderful. Let's try something just slightly more aggressive then. That was the thicker one. Here's the thinner one. Alright, now let's look at the edge. Let's see, this is the thinner one.
miraculously completely fine. I think I like this steel. Let's see. I think I like this steel a lot. Also, completely fine. It's a little bit dirty, but it's not like dented or breaking or anything. Let me look at this really close just to be sure. And no, yeah, they're completely fine. That's nuts. Alright, well, that's more trauma than you'd put just about any knife through for a tip like that. So now what we're going to do is, since these were originally designed to be test pieces anyway, that's why I didn't put a tang or anything on them, I'm going to see how they handle some extreme, like, braking type test. Then we can also look at the grain structure.
Alright, now we want to be real big careful doing this. And we're going to super duper carefully ratchet this back. And we're going to see how much it takes to break, like how well it handles itself. Alright, so I'm aiming to get the point kind of right back at the very start of that curve. Super careful. Ooh, already heard the tip break, so that's interesting. So it doesn't take a ton of lateral force to, I think it's lateral force, whatever. Let's see how it handles. Oh gosh, let's see. Ooh, okay. That's pretty hard. I'll do one more, just for the sake of it. There we go, that's what I was after. Alright, now we're going to try this one. Ooh. This one's way more. There we go. That was more like what I was hoping for. Tells me I think I like the 415 degree temper more. Let's look at the grain structure after I pick up these pieces.
Alright. So we've got the thinner one and then the thicker one. Both of them have really fine grain structure, so that's good. It's nice and compact, and it's uniform too, from what I can tell. It's kind of got a like almost chalky sort of appearance. That's more in line with what you'd want. That tells me either of these is probably good for this application, but personally, this one being thinner and it bending more first before breaking is more ideal. So I would be going with the 415 degree temper for sure. Now what we're going to do is we're going to hammer break each of them further down, and this will be more of like the tell-all sign of which one's probably going to be more ideal. Here I have my 8-pound sledgehammer. And I'm just going to do like kind of a let it fall into it sort of method. We'll see how it goes. Handle that well. There's 3 of those. Now I'm going to try striking it. Got 2 hands on it. I'm going to hit kind of at the top. There we go. Not too bad. Broke a bit easier than I was hoping though. That's the thicker one that was tempered at 400 degrees. Let's see, the grain structure on it is a little bit bigger, it looks like. Which
I think this one was tempered or quenched a little bit hotter too, so that's probably partially to blame. We're gonna check this one now, see how it fares. Again, just gonna kind of drop it. Alright, 3 did fine. Do a two-handed hit kind of at the top. Also broke. Interesting. Well, grain structure is about the same on these. So that's interesting. Granted, that should be way more force than they'll ever be under. I want to try something real fast with the remainder of this. I want to see how it handles being bent. Well, here we go. That's interesting. It looks a bit better actually right there. Grain structure is just for this one. It's a little bit more uniform and compact. This one's a little bit more granular. So that's probably fun. I might up the temperature just a little bit on the temper cycles for the roll knife. Okay, so we figured out the technique that we're going to use, and we also figured out that this steel is incredibly tough. We'll do a careful quench in oil that's been heated to about 115 degrees. Then we'll temper in 425. I feel like would make it just like a little bit less hard, because these are really hard blades. Like, I read in a forum recently that ADCRV2 gets harder than Chinese arithmetic, and it's like, yeah, that's that's definitely been my experience with it so far. It is really hard steel after it's been quenched. So interesting. This has been super informative. Okay, time to collect the little pieces, and yeah, I guess we'll start on the real knife. Now, you might have been hearing me mention the real knife. I've been doing these tests because I have another commission lined up. Yay! More information on that soon. Alright. Catch y'all next time.